All right, hello, welcome to a new video. Today we're in this problem called number of provinces, number 547. It is a depth first search graph problem. So we can do it breadth first search, but LeetCode says to do it in depth first search. So yeah. I've been thinking about this problem for about like 20 minutes or 10 minutes, and I think I might have a solution for it. And I was just thinking about it in my head, like, could this work with this? But if I have to do this, no, if there's like this, then I have to do this, right? As like that type of stuff. So yeah, I've been thinking about that, and I think maybe I could have a solution, maybe. So let's just go ahead and read the problem. So there are n cities. Some of them are connected, while others are not. If city A is connected directly with city B, and city B is connected directly over with city C, then city A is connected indirectly with city C. That makes sense. A province is a group of directly and I think it should be directly and indirectly connected cities. I think that's what it should be. Yeah, province is a group of cities that are just connected in a graph. So and no other cities outside of the group. Okay, so you're given a 2D list named is connected, where is connected I and j could be equal to 1 or 0. If it's 1, then they are connected. If 0, then no. So that's cool. Okay, so for our inputs, we're given 2D list of ints named is connected, and then our output's supposed to be return a total number of provinces. So int provinces, where we say note that provinces, or we can just say like what are provinces. We know that provinces in my own terms is just like a connected graph of cities, right? Doesn't matter if not direct or indirect. Um, province can contain both. Oh, I say let's say or because yeah, okay, makes sense. So yeah, so that's a province. So basically a connected graph. And then that's pretty much it. So now let's go into um yes, let's go into the planning phase. No, let's go into the matching phase actually. No, example. Example. So let's say we have a graph like this. It's like 1, 2, 3, and 4, right? And then now I say that they connect like this, right? So there is two connected graphs. There is one right here. Oops, what? There's one right here, one right here. So that's two, right? So that's an answer for that one. What if the graph was connected like this, right? I'm pretty sure the answer here would be it would be like 3 because there's one graph here that one connecting the 2 and 3 and 4. 3 and 4 are considered their own graph because they're just a single node in the graph. So I guess and they are they are they're their they are their own province because oh no, right? And so yeah. So the answer is 3. So now what if it was this what if this was the case where it's like 1, 2, and then 3? I don't think it really no 1, 2, and then 3. They didn't say it was I'm pretty sure it doesn't really matter. So yeah, I think if this was the answer, then it would be. I mean, if this was the case, then it would be 1 because they're all connected. So there's only one connected graph, right? So those are my examples. I think those examples are okay to like kind of showcase like what could be the case. And then I should also should have said like the input. So like for this, the input would be this is like one 1 0 0, and then this one is 2 is like 0 1 1 1, and then 3 is like no wait no is it like direct wait oh it's a goes in both directions. I forgot what kind of graph that's called, but yeah. Okay, so this would be 1 1 0 0, right? And then this 2 would be 1 1, and then 3 would be 0 1 1 0, and then 4 would be 0 1 0 1. I'm pretty sure that would be the answer. I mean, this would be the array for that. So yeah, maybe we'll go over an example later. I'm like, we'll go over like I don't know, just something about that. So yeah, I'm pretty sure that's it. Let me double check. Yeah, okay, I'm correct. I'm just looking at it. I'll be back. All right, my bad. I forgot why I went AFK or whatever. I honestly forgot. I was watching Fed Heart TikTok. Anyways, where was I? Um, yeah, I did the example. So let's go ahead and kind of match. Yeah, oh yeah, I was trying to get my water. There you go. I already drink my water. All right. So, anyways, let's kind of figure out what we can use to solve this problem. Well, obviously, we're gonna use depth first search. Use depth first search. I'm thinking what I want to do is yeah, what I want to do is I want to get like the node. Oh wait, no, I want to get. I can't say node because this is a 2D list. So I want to get I want to get um I want to get city, and then I want to get previous. So what I mean by this is I know we're gonna get the city, right? So we're always gonna start at 0, technically, right? And then 0 is going to go. Let's just say it was like this one, right? So we know we're at 0. Can I just do this? So we know we start at 0, and then we had to go through like a for loop, like for I, like the size of like how many cities there are, like in general. I'm pretty sure there's like 4 cities, right? So that's 4. Not sure what's like that. But anyways, let me just do this. Okay, cool. Yeah, it should work now. So, um, start off with 0, and then for I in range, all the way up to the length of the cities that there are. We're gonna go through everything, but we're gonna skip the index, the current index. So I guess we say like for loop up to length of cities of input list. And then we're gonna go to number 1 or index 1 technically because this is 0 and this is 1. So we're gonna go to 2, and then 2 is gonna be like okay. So so what I have is I don't know if I'm like a part of a province or if I'm something completely new, right? But if it is the case and such that my previous is something that I've already seen. Let's just say I've already seen this, right? Then I'm not a new province. So I'm going to cancel myself out and say that I do not count as a whole different city, right? I'm a part of a province. And so what two's going to do is two's going to be like, okay, So now what I'm going to do as number two, I'm going to go through all these elements, right? I'm going to skip what I've seen already and myself. I'm going to skip what I've seen and myself. And then I'm going to go to three first, and then three is like, okay, my previous was two, and that it has already been seen. So what I'm going to do is I'm going to not count myself as a province, right? And then I'm going to go through my own cities, right? And then what it's going to do is going to, of course, it's zero, so it's not going to go through it. And then it already has seen two, so it's not going to go through two. And then it's itself, so it's not going to do anything. And it hits zero again, so it's going to stop, right? And so now we're back at two. Two is like, okay, this four. Let's go to this four because it's a one. And then this four is like, okay, my previous is two. Two's already been seen, so I'm not a new province, so I'm gonna count myself out. Then four's gonna go through all that stuff, and then now, um, at this one, we're gonna come back and say that we're gonna come back and say that okay, so basically, if it's not been seen already, then we're gonna count it as a province already. So we're gonna have a variable int res. We're gonna do count as province if increment by one if province, then if if statements like if prev seen then not province and stuff like that, right? And so that means if we have a scene, then we're gonna have like scene list bool times n, right? And I'm pretty sure that's fine. I mean, we can say like if prev could be equal to none, and then if prev equal to none, then don't do anything. Well, my brain's kind of big today. Holy shit. All right, anyways, yeah, everything in the match sounds correct. Seems like it does work. So, um, let's go to plan it out, right? So let's go plan. We're also gonna have res equal to zero. Oh yeah, I forgot to ask some questions, but I don't think that really matters. The question is like, what's the min size of the graph, which is one, so that's fine. Res equal to zero. Then we have bool. Let's get the length. So it's equal to the length of inputs, and then we say like scene is equal to scene is equal to list of bools false already and times n. Then we do we have to write our depth first search function. So BFS node and prev. And then we call DFS on it's not node, it's value, city, prev. I guess we can initially call DFS on zero and none with none, and then just return res. Right, and then I think non-local res, right? Because it's outside of the DFS, but that's fine. Anyways, so first things first, we have to say so. We obviously want to do like for I in range, to the length of input at city. I mean I think because won't I be equal to n? Okay, it is. Okay. I of n. I all the way up to n. Can I just say local? Non-local n. Right? I can do that, right? I range all the way up to n. Or I can just say like that doesn't matter. What do I want to do? So at this point we're at the city. Oh wait, I am back. Um, so for iron range, where was I? Was I? For iron range, so what are the cases? So if is equal, I equal to, so for if I is equal to, um, if I is equal to city and skip, then if I equal to 0, skip, and then if I is equal to, so if I is equal to 1, then we have these cases. So if seen, then skip. Else, oops, why did else then we do say res is equal to 1. Wait, no. If no. If we haven't seen I. No. What am I saying? Okay, so let's say if we're at 2, right? So if 1, then if seen, skip. Else by scene, so if city, wait, no. If inputs at city at I, yeah, skip. Then else, then we do that first search with it with, so that first search, the first search, next city. I think I'm just naming it, so next city to input, city and then I, right? So if next city scene, then skip, not, then we go to next city with prev equal to city. But are we gonna say that, like, if we, hmm, hmm, we're gonna say if it fits its own. So to, so if prev, okay, so we're gonna say like from the get-go. So if prev, if scene prev, if scene prev, if scene prev, then then do nothing. So if not scene prev, so basically if prev, if scene, If wait, oh, wait, do I see? Maybe I don't know. I mean, I do understand, but I just don't know how to code it. Because what if this is the case where it's like this, right? What if this is the case? It is Monday, okay. So what if this is the case? Right, what do I do here? How do I access? How do I access 4 and 3? How do I access 4 and 3? Well, what I can do is I can be like, oh, it's kind of wacky, but what I can do is I can be like, towards the end. I don't know, it's kind of slow. There's gotta be a better way to do this. So I gotta do this. So if so I gotta do this. So after this, after we do the initial call, we gotta go through all the other ones that have not been seen. So for I range all the way up to n, if I if scene list at I equals to false, then I have to run depth first search on it. So depth first search of I And then I and none. And then that should solve the case because once we're done, we would have one, and then we have to go through again. So one has been seen, two has been seen, but then we left with four and three. Right, in this case, go through four, say plus one, so it's none. And then that's kind of it's kind of slow, is it? Oh no. Okay, but what if it was like this, four and three? So we're at four, and four is like, okay, my previous is none, so res plus plus, so now it's not two. For ein range, up to n, which is four, zero, zero, skip, skip, then one, which is three. Then it goes to three with next city is equal to three, and city and previous is equal to city, which is four. Okay. Oh wait, I'm doing it the other way around, but same thing. Then three is seen. Three because previous is okay, three is seen, and then four. I mean, I think it's fine if I just do this, right? No, I think I'm doing it wrong. I think that's the code, right? And then we can say that then we say that then I think guess we can say like Next city is equal to city. What if next city? Well, next city should be I. Then we say that if input, oh wait, what? No, because okay, wait. Oh, city. Okay. Okay, yeah, I think that this works now. This works. This works. This works. This works. This code's working. But I don't get what this means. So this is true. Okay, cool. I'm just thinking like this I should be doing this when I'm actually coding, but like how much time has it been? Oh wow, it's been like 30 minutes. Okay, so I should speed it up. So let's just go copy paste our whole code. So we have res equals 0, n is equal to the length of our input, which is just what's it called? Is connected. It's kind of a weird name. The scene is equal to scene is equal to n and search with the city. Okay. So we're gonna let local res and then so if we so in that for search, if we're at the city, then that means that have seen of city is equal to true. And then if prev is equal to none, then res is equal to one. Okay. And then I in range all the way up to n, where so if input So if is connected with the city, and then at I is equal to 1, then I'm gonna see. So if the city, so if we have seen city, then continue. Else, we're gonna call that first search on the city. So I and prev equal to city. Oops, forgot to define. And then this whole code we're just going to be like, so for I in range, let's say n. So if have seen at I is equal to false, then we're going to do a first search on it. And we're just going to return res. Oh, I forgot. I'm a genius. What the fuck? What the fuck? I'm a genius. I'm a genius. Dude, I saw that solo. Holy shit. All right, so that was kind of fun. That was actually kind of fun because I was like talking like I'm in a TED talk, like yipping yapping. But anyways, so that is yeah, I might have to edit this video because I exposed some things that I shouldn't have. So that is Oven time complexity because we go through every node once. Thanks to our if statement, we'll go through every node once because we've seen it already. Then for space, we're using O of n space, unfortunately, because for every city in the list, we're putting that as a true as a boolean. So yeah.